Hello everyone, welcome to the course, and today's topic is linear regression. So let's understand exactly what is the meaning of linear regression. So if I am saying what is linear regression, so regression is a concept in which we are going to calculate the value of some dependent variable using independent variable. Yes, so this is the basic definition of linear regression. Predict a continuous dependent variable that is called as target variable is based on one or more independent variable that is called as predictor variable. Now let's understand the meaning. So if you want to predict the value of one variable using we can say that using one variable or more variables. So this is the concept of regression. Let's take the example. So if we are having a height of the person, and according to the height, if you want to predict the weight of the person, so yes, your weight is your dependent variable and height is the independent variable. So this is the basic concept of linear regression. So it is very simple. Why? Because in linear regression we are going to calculate the value of any dependent variable using some independent variable. In mathematics, if you remember, if I am writing y is equal to plus 2x, here we are having one simple equation, y is equal to 3 plus 2x, where we are writing put x is equal to 1. So using x equal to 1, we are going to calculate the value of y. That means y is equal to 3 plus 2 1, which is 1s are 2 plus 3 5. That means the value of y is totally dependent on variable x. So in order to calculate the value of y, we require the value of x. So where this y is known as, yes, it is dependent variable. Friends, it is dependent variable, and the x, this particular x, is known as independent variable. And okay, now we understand exactly what is the meaning of linear regression. So linear regression is used to determine the extent to which one or more variables can predict the value of the dependent variable. It is also required, guys, whenever if you are calculating the value of dependent variable, it may be possible you are using only one independent variable. It may be possible your dependent variable is dependent on multiple independent variables. Yeah. Let's take the example. If you want to calculate the blood pressure of any person, right? So it is totally dependent on, we can say that age of the person, we can say that gender of the person, whether it is male or female. So here we are having multiple independent variables on which this blood pressure is dependent. Clear? The basic concept of linear regression. Now, what is simple linear regression? Again, it is, guys, so simple linear regression is an approach for predicting a response using single feature. Yes, when we can say that our linear regression is very simple, when you're dependent, when you are having only a single feature by which we can calculate the value of dependent variable. So simple linear regression is an approach for predicting a response using a single feature. So here we are having two variable. One variable is, that is, we already know, that is called as dependent. Second is independent, and both the variables are linearly related. One of the important point, guys, they are linearly related. So if I am saying linearly related, that means what? If you plot the graph of both the variable, that is x and y, we get some straight line. Yeah, straight line. And using that straight line, this is my, we can say that function, that using that straight line can calculate the calculate value. Okay, so here we are going to, we try to find a linear function. If I am saying linear function, so this is the function in which the highest power of the variables must be 1. That's then we can say that is a linear function that predicts the so if I'm saying y is equal to 2 plus 3x, so can we say that this is the this is linear function? Yes, because power of y is 1, power of x is 1, so it is linear function. So we try to find a linear function that predicts the response. Okay, we can say that here we are predicting the value of y using the variable x. Okay, let's understand this concept using one example. Okay, so guys, here we are having two variable because we are talking about simple linear regression. In simple linear regression, we are having single feature by which we can calculate, we can predict the value of dependent variable. So here we are having some, again it is supervised machine learning a concept, because in supervised machine learning we are having a, we can say that variable x, here variable y. For value x, yes, the value of y is 1. For value y, so for x equal to 1, the value of y is 3. 2, 2, 3 and 5, 4 and 7, 5, 8, 6, 7, 9, 8, 10, 9, 12. So for each and every value of x, we are having its corresponding value of y. Okay. So the value of x is known as feature vector. Okay, guys. So the value of x is known as feature vector, and it is always denoted by x1, x2, x3, x4, dot, 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 xn. But in case of value of y, it is called as response vector. Why it is called as response vector? Because y equal to 1 is a response of x equal to 0. Okay. We can take the example, we can take this variable x as any we can say any parameter. For x equal to 0, y is always equal to 1. For x equal to 1, y is always equal to 3. We want to calculate the value of x when it is 0.5. So it may be possible you are getting the value between 1 and 3. The value of y between 1 and 3 may be possible. So that's why this x is known as feature vector and this y is known as, guys, response vector. So feature vector is always represented by x, that is x1, x2, x3 and xn. Let's consider n number of values. And in case of response vector, it is denoted by using variable y, and every value will be y1, y2, y3 and yn. Clear? Perfect. So again, if you want to create the model for this data, so yes, we can take the example of scatter plot. Yes. So here we are having, guys, variable x, we are having variable y, and for each and every variable, guys, when x equal to 0, yes, this the value of, we can say that y is 1. If you remember, perfect. For 1 it is 3. For 1 here it is 1 and this 3. Perfect. For 2 it is next one. So this is the diagram we have plotted given data. Okay. Now, so after plotting this particular graph, the most important part is the task is to find a line that fits best. This is the one of the most important part. So guys, here we need to calculate, we need to find the line that fits best, and that line is known as regression line. That line is known as regression line. So guys, let's find the best fit. So here in this particular diagram, so if we draw, for example, if you draw one line from here to here, okay, so can we say that it is a best fit? We cannot say that. Why? Because it is very close to this point, this point and this point. What about these points? So it is not very close to this point. That means get some error value. Okay, so because we need to draw one line that best we can, when we can say it is a best fit, guys, when it will consider all the points equally. Okay, so here what we are going to do, another line. So if you draw one line from here, so again it is close to these points, but it is not very close. Again, it is not a best fit. Because if it is not a best fit, that means if you are going to calculate the value of, for example, let's take the example, we have drawn this particular line. So here calculate the value of y for this particular point, guys. Again, some wrong value, or we'll get some value with error. So in that scenario, we need the best fit. So how we are going to create the best fit? Again, this is only possible when you draw the line passes, you can say that middle of these. Okay, so here again it is close to this point, again this is my called as regression line, as this. So in linear regression, one of the important criteria, you are having your data, we need to calculate the best fit line, and after creating the best fit line, this particular line having one equation, and guys, that equation is known as h of xi, which is equal to beta 0 plus beta 1 x, right? So h of xi is equal to beta 0 plus beta 1, where this beta 0 is known as y-intercept. Guys, it is y-intercept. Okay, this beta 0 is known as y-intercept. And what about beta 1? Beta 1 is known as slope. But in regression, guys, in regression, this beta 1, because in geometry, it is very similar to this particular equation, which is your y is equal to mx plus c. So if you compare both the equation, so the value of m is, the role of m is playing this beta 1 and c is your beta 0, where we already know that c is your y-intercept, beta m is your slope of the line. So this particular line is having slope, and that slope, that is m, is represented by using beta 1. And again, this line is, we can say that intersecting y-axis at some point. That point is known as, okay, so that's why this equation is having two components. First one is the value of n and the value of c. We need to calculate the value of m and c, or in other words, I can say that we need to calculate the value of beta 0 and beta 1 using these data. Then only we can say that this is the best fit, because practically how we are going to find the this equation, because beta 0, beta 1, these are the two constant values. So how we are going to calculate the beta 0 and beta 1? So if you take the help of mathematics, so students, let's take the example over here. So if we are having one equation, example like we are having y is equal to a plus bx. So here we are going to create two equations. Think this y equal to a plus bx. We are going to use to calculate the value of a and b, where b is your, yes, slope and a is your y-intercept. Yeah, you can use any variable, don't be confused. Okay, because you must be thinking like, sir is using beta 0, beta 1, sir using m and c, sir is using, all are same. Perfect. So let's take the equation summation y is equal to n plus x. How we are going to calculate the value of these? So first of all, we have multiplied this summation to each and every values. Summation y, perfect. Here a, okay, a is a constant. Whenever if you are applying summations, it is always with variable. A is constant, right? So here we are getting 1. Summation of 1 is, guys, 1, n. Summation of 1 is, for adding 1 5 times, so 1 plus 1 plus 1 plus 1, which is 5. So if you are adding 1 n times, you will get n values. So here we are considering summation of y is equal to a, where summation 1 is given, summation 1 is n plus b as it is. Now let's multiply this particular x, summation of x y equal to a. What is the value of n? It is summation 1. When you multiply this 1 into x, you will get summation x plus b summation of x. Here, guys, we are having two equations. Okay, so these, in this equation, we need to calculate the summation of y, summation of xy, summation of x, summation of x square. How we are going to calculate? Yes, using, because you are having the value of x and y, guys. Okay, you are having x, you are having y, you are going to calculate the x square, you are going to calculate the xy. That's it, very simple. Okay, so from here you will get summation x, summation y, summation x square, summation xy. So you are having all the values. We are going to substitute all the values in these two equations. After that, we are going to solve these two equations as a linear equation, and after solving, yes, we will get the value of a and b. So after getting the value of a and b, substitute values in this particular equation. Y equal to a plus bx, which is known as regression line, or in other word, I can say it is the best fit. So guys, this is basic funda of linear regression and simple linear regression. I hope you will find the simple things in particular equation, particular concept. Thank you so much.